The course on semiconductor physics consists of 4 parts: quantum theory of solids, carrier statistics, drift and diffusion current, and carrier dynamics. In quantum theory of solids, we start with crystal structure, describing how atoms are arranged in a semiconductor. And then we will discuss energy band structure, what gives rise to energy band structure, and how energy band structure dictate materials' properties. And based on the electrical properties of solids, we can classify solids into metal, insulator, and semiconductor. And we will then discuss the key characteristics of semiconductor that makes them so useful. And then we will discuss how electrons are distributed in the energy bands of a semiconductor. And we will do so by first evaluating how many available states are there in each band, which is described by the density of states, and then the probability function that gives us the probability of finding an electron at a given energy. We will then discuss 2 types of semiconductors, first intrinsic or pure semiconductor, and then extrinsic, which is a doped semiconductor. Here you will see how one can tune the conductivity of a semiconductor over a very, very wide range, a property that makes semiconductors so very useful. And then we will discuss how these carriers can produce current. There are 2 types of currents that are possible in semiconductor. First is a drift current, which is driven by an applied electric field, and then diffusion current, which is driven by the non-uniformity in carrier concentration. Finally, we will discuss carrier dynamics and how carriers may recombine and disappear or generated by some external stimuli. We will then develop a theoretical framework based on continuity equation, which gives us a complete description of carriers' behavior, how the current flows and how the carrier concentration changes under various conditions, which are readily applicable to the real semiconductor device operating conditions.